All right, if the triangles are congruent, then all of their corresponding parts are congruent. If the triangles are congruent, all their corresponding parts are congruent. So this says, given that triangle XYZ is congruent to triangle PQR, draw, literally, draw conclusions. If the two triangles are congruent, then all their angles must be congruent, right? So I can see from the way it's named that angle X is congruent to what?
P.
P. So I'm going to mark that. Angle X and angle P are congruent. I can also see that angle Y and angle what? Q are congruent. So I can mark that. What's the last thing I can see?
Z and R.
Z and R are congruent. So I'm going to do that with 3. All right. But there's 6 congruent parts. So I need to do the sides, don't I? Okay, so let's start here. Between this single and this double, I'm going to do this side. Its corresponding part is also going to be between the single and the double. Yeah? The double and the triple, I'm going to mark that side, is also going to be corresponding to the side that's between this double and triple. Right, Connor?
Right.
And then here. There are 6 corresponding congruent parts.
1, 2, 3, 4, 5, 6.
Yeah?
Yeah.
That's all you got to do for that. Draw conclusions. Okay?
Alright, let's go.
All right. This is a property we refer to as CPCTC. So let's write out what it means here. The first C is I know it's on the board, but let's write it here. Corresponding parts of congruent triangles are congruent. C, P, C, T, C. So if we can prove 2 triangles are congruent, if we can prove that, then their various parts are congruent. So totally, up until now, we've always had to prove that 2 triangles are congruent. Well, now they're asking me something different. They're asking me a part. You say, okay, prove that angle U is congruent to angle Q. Well, it's the same thing. We still have to prove the triangles are congruent, and then we can say these parts are congruent because of that thing. Okay? So it's one more little tiny step that we have to do. So, the first thing is, you guys already wrote your givens, yes?
Somewhat.
That's an easy one to write. Just write it like that. UQ and VP bisect each other at A. All right, now I'm going to mark up my drawing here. If UQ bisects VP, then I know that these segments are congruent by the definition of what? Yeah, use this word here, the definition of bisector. If this bisects this, then I know that those segments are congruent as well. Definition of bisector. What is one more thing I know, even though it wasn't given to me? Alexis. Absolutely. This angle is congruent to this angle because of the vertical angles. All right, I've marked everything I can. Cover up one of the triangles. And which postulate will I use? Side, angle, side. SAS. That's what I'm going to use, okay? So that means I need to prove sides and angles and another pair of sides congruent. So let's start with one of the sides. So I'm going to say UA, I'm going to start right here. UA is congruent to QA by the definition of what? Bisector. Go up here and say, what word did they use here? I'm going to say definition of bisector. Okay, if this helps you, cross off an S. You've proven one pair of corresponding sides. Now let's do the angle. So, ladies and gentlemen, we can't say angle A because we got two different angles we're talking about. You have to say UAV or VAU, whatever. Okay? Angle UAV is congruent to angle QAP. How do I know that? How do I know those angles are congruent? What? Because they're vertical angles. Right on. Okay, I've proven that the angles are congruent. Cross the A off. The last thing I need to do is that last set of sides. So I already did this, so I got to do these two. Segment VA is congruent to segment PA. How do I know that? Definition of bisector. Stop whining. I'm not going to answer. Okay, so side. I did the three things I need. Now I can say that the two triangles are what? I'm going to do my congruence statement. I'm going to say triangle, don't turn the page yet. UAV is congruent to triangle QAP, making sure I do it in the right order. I can't hear what you're saying. What? Oh, I know, I'm not there yet. Hold on. Not there yet. So this is congruent because of side angle side. But look, we have to prove this. We have to add one more statement in here, proving that angle U is congruent to angle Q. Well, we've shown that the two triangles are congruent. So that means I can say that this is congruent to this because of what reason? CPCTC. If the triangles are congruent, all the corresponding parts are congruent. So I'm just going to say because of CPCTC. Sweet, huh?
Yeah.
Gotta admit, it's one extra little step. Okay, here we go. Shh. Ladies and gentlemen, if we get parallel lines, we better believe we're going to be working with what kind of angles?
Right.
Alternate interior angles. Segment AD is parallel to segment BC. I'm doing my little triangle thingies. Actually, I'll probably do it like this.
Yes, ma'am.
Okay? Parallel lines does not mean that they're congruent,
But it says it.
but they're parallel. But in the next statement here, it says that these are congruent segments. I'm going to write my givens real quick, even though I know all of you have done it already.
No, I did not.
Oh, I did.
Okay. What other side do I know in this picture is congruent to itself? Oh, this is given. Yeah, this is congruent to itself, isn't it? Because they gave me that. They said that AD was congruent to BC. Parallel and given. Okay. It's a screw up. Okay, now, look, because these are parallel lines, and this is the transversal that cuts those parallel lines, can I say that these angles are congruent? How come? Alternate interior angles.
Holy
Right
moly.
on. Isn't that cool?
Dude, that is awesome.
However, I have another pair of alternate interior angles. Right. Okay, that's going to be also, those are congruent.
Well, wouldn't they be?
Now,
Yeah, you know what?
I think we've marked everything. Let's cover up and see what we can do. We can do angle, side, angle. Yes?
Yeah.
But you know what? Since they gave me this side as being congruent already, it's already a given. It's one less step that I have to do. We could also do angle, angle, side, couldn't we?
Yes,
And this one was already given to me. So I might as well just do angle, angle, side. I'm going to write angle, angle, side.
A.
What? Okay. Now, I have to prove two angles are congruent, and I have to prove a side. Well, they already told me that the side was congruent. Right here, side AD is congruent to side BC. So I've already done my side, so I'm going to cross that off. They gave me that, right? So then I got to prove a couple of pairs of angles are congruent. Let's start with this one right here, the single mark that we did, the single mark. How do I name that angle right there? That angle right there, how do I name that? Angle BAC. BAC. Okay? Angle BAC is congruent to the other little single mark here, which I would call probably,
CAB.
no, DCA
DCA.
or ACD, whatever you want. How do I know they're congruent?
Because it shows
Because they're what kind of angles?
alternate.
Right in,
Interior.
right in. Alternate interior angles. I've proven one pair of angles are congruent. All I have to do now is that last pair of congruent angles. And that would be the double ones. No, there's no 90 degrees in here. We don't know that. Okay? So the double one is going to be DAC is congruent to ACB. This right here, ACB. By the alternate interior angles again. All right, I did that other pair of angles. Now I've done my AAS. I can say their triangles are congruent. Triangle ABC is congruent to triangle CDA. I have to make sure I'm going in the right order. I have to look at it, actually. I have to say, make sure I'm doing this in the right order. By what postulate? AAS. But we're not done. What do we need to prove? And we need to prove that AB is congruent to CD, AB is congruent to CD. And we know that because of what? CPCTC. If the triangles are congruent, all the corresponding parts are congruent. It's a beautiful thing, isn't it?
Beautiful, it's gorgeous.
It's like a puzzle.
Okay. So the rest of this is pretty short. So in this diagram right here, SET is congruent to DAY. Why can we conclude then that angle S is congruent to angle D? How can we conclude that? Because of what? Yeah, if this is congruent to this, all the corresponding parts are congruent, so the angles are congruent because of CPCTC.
Don't make
So why then can we conclude that ST is congruent to YD? Why can we conclude? Oh, that's right, CPCTC.
Guys, then that was
All right. Tell which triangles you need to show are congruent in order to show the statement is true. So we need to prove this. Before we can prove that, we have to prove the triangles are congruent. So let's just look at this real quick. We were told this was congruent to this. They're both right triangles. What's one other thing we know is congruent? Right? Because of the reflexive property. So let's cover this up. What would we use to prove these two triangles are congruent? ASS?
No.
Can't use that, can we? But we can use HL. So, if triangle ABC is congruent to triangle DBC by HL, then segment AB is congruent to segment BD by what? You got it, CPCTC.
That's weird. Same CPC.
Okay, let's do this one. We're not going to do C right now. We're just going to do A and B. Study the triangles below. State why the triangles are congruent. Well, let's see what we have. We have an angle. We have another angle. What else do we know is congruent?
There's reflection property.
This right here. So if I cover up one angle, everybody look.
Angle?
Which pos- angle, side.
Angle side.
They're congruent by angle, side. This is the last little thing we got to talk about. State the pairs of congruent parts by CPCTC that will help you set up equations to solve for X and solve for Y. So if I know they're congruent, that means that this is congruent to this. Yeah? Gentlemen. That means I can say that segment AP is congruent to segment AC. I can say that because of CPCTC. If I can say that, oh, then look what else I can say. 5x plus 4 is congruent to 9x minus 12. And we get to use all our favorite algebra to solve for x. So you could do multiple steps here. I'll start by getting rid of 12. I get 5x plus 16 equals 9x.
X equals 4. Done.
Yeah. Subtract 5x. 16 equals 4x. X equals 4. It doesn't matter. You can still get x equals 4 no matter how you go. There's no way which way you go, you get x equals 4. Okay, then we can do the same thing for these two, but we're not going to, okay? Now, ladies and gentlemen, flip it over. You got to take some stuff off of this homework.
Thank you, guys.
I don't remember what it was, but...
Let's hear something different.
Credit tomorrow?
Huh?
Is this going to be a great tomorrow?
I am not going to answer that question.
So,
All right, so this page is exactly like the notes. Refer back to the notes if you're not sure what to do. Look at the back page. There's 2 proofs.
big X, right? Big X first.
But because you don't ever rhyme, I'm going to let you just choose one to do.
Well,
Really
I
cool.
would choose either.
But you are more than welcome to do both of them.
Yes, credit.
Listen, you guys have like 18 minutes. You should definitely be able to get this homework done. Definitely.